Hello and welcome to my class. I'm Grolin Annesley from ThinkMO Education. I'm currently a Cisco Technological lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 5834444290. Today's topic is IP address. In the last lesson we talked about the basic concepts of the overall network and a 7-layer reference model, including 2 key parameters in the data link layer, source MAC and destination MAC. We revolve around one of the most core parameters in the network layer today. To explain to you IP address. That before we start class, let's review the main functions responsible for the network layer mentioned in the previous lesson. We mentioned the physical layer earlier. For example, a transmission medium used to connect physical devices. Finally, the connection of the device can be formed and pass the signal inside. Well, it's better at the physical layer. Data link layer. Actually both. More are responsible for the content on a link, or responsible for a function on a link. Then after reaching our network layer, we're going to open up our eyes. The network layer defines, appearing in our network worldwide, every device, every node. Its location is a global concept. The data link layer is relatively. Its pattern or scope will be smaller. That is IP address. It's like we send courier. The 2 most important parameters. That is your sender, recipient, and your address. No matter how many transfers there are, then the IP address will not be changed. We are in the 3rd floor. How to accurately find such an IP address, and how to achieve correct forwarding. This is in our network layer. The functions and responsibilities that the IP address is to provide. So our core today. It's all about IP addresses. It actually has quite a lot of content. We're going to talk about the basic components of an IP address, including its classification, and some special IP addresses. There are also 2 techniques used for IP addresses. A variable length subnet mask. One called VLSM. That is SuperNet. There is a lot of content in this class, so I hope you will listen carefully. We are now officially starting classes. I believe everyone should have heard the term IP address before. We are network engineers. You must be familiar with IP addresses. First of all, let's be clear. IP address plays a role in global positioning. This is the core of its role. Then the IP address will work in a wider range. As long as you need the network layer for data forwarding, all need an IP address. This is where it works. So for the MAC address we talked about in the last lesson, relatively speaking, its scope is smaller. It works on a link. A link refers to a logical link. For example, we have several devices connected to the same switch, without any configuration on the default switch, actually equivalent to our devices. Both work on a logical link. That is MAC address. It has a smaller scope. IP addresses provide global location. This is the difference between MAC address and IP address. I just draw a picture for you. Let's take a look together. Scope of their role in the network. For example, now this is a switch. I take what I just said, draw it for everyone. Here are the 3 PCs below. When the company is online, export to a router. So we first put these devices connected to each other. Then the working range of MAC address. Actually in this area, all devices are connected to this one switch. We call this way logical interconnection. The logical interconnection is not a real physical direct connection. There is a difference between them. For example, if you look at the difference between the two devices, PC1, PC2, data can be transferred between them. This data will be sent to the switch first. Then send it to PC2. PC1 and PC2 are logically directly connected. But they are not directly connected physically. What we call a direct connection in the physical state. Through a line. Connect PC1 and PC2 together. If their data is transmitted over such a physical link, we call it physical interconnection. But not now. Although they are not interconnected by a real wire, and made a transfer through the intermediate switch. But it's still a direct link. We call this the logical interconnection. Then the range of MAC address work has a range here. In fact, in such an area, for example, the current operator going to visit some services on the public internet in the future. This is the service provided by the operator on the public network. I also connected the router from the company's outlet. Also connected to a server on the public network. Let's say this is a Google server. Then if I pass the MAC address, want to access Google from this device, it's out of the question. Because the scope of MAC address work ends here. In the future, we will slowly start to learn the configuration. Everyone from MAC and IP will have a deeper understanding. But in the early stage, everyone must have a basic impression. The switch can use multiple network ports on the body. Connect multiple devices to one. This state is called logical interconnection. Then you need to locate a certain address on such a link. What we need to look at is a certain device. Depends on the IP address. Then if an interface of the router connected another link, such as operator, the address where we are going to work is the IP address. The MAC address no longer has the corresponding function. There is no way to cross our logical link and transmit the corresponding information. So the MAC address works in our layer 2 environment. Once the future has to cross the second floor, we have to jump out of this logical link. Can't use MAC address. Now we're going to use the IP address. That is, we have a new parameter. IP address. When data is forwarded, we are forwarding by querying IP from one device to another. For example, a return package from Google. Back on this device. The device will query the local routing table, also called IP address forwarding table. Then the data will be forwarded. After that is the MAC address and its working range. So, the two addresses are actually used in combination. It can be easily understood as MAC is to locate the local address. IP addresses, global addresses. That's in our overall data communication. IP addresses never change. The MAC address varies with the link. It will change. This is the difference between them. Here are some recaps of what came before. So let's take a look now. Other than IP address, what else we'll see today? First, there is an IPv4 address here. When I told you about the IP header before, I should have mentioned there are two versions of the entire IP protocol. One is version 4. One is version 6. We will only be exposed to version 4 during the NA phase. It is also the most used version in the corporate network now. It's also the big version we're using now. Because of the migration to IPv6. Relatively far away. IPv4 is what we will talk about today. Next. Look down. There's something called a subnet mask here. That's the core of what we're talking about today. Including a default gateway behind. In the future, when we talk about data communication across network segments, we will talk about the concept of gateway. Today we mainly talk about IPv4 and subnet masks. Some connections between them. For example, I will write you an address. 192.168.1.111. I also write the mask on it. 255.255.255.0. Let's not focus on its specific use. Remember these numbers first. I don't know if you have any knowledge about the encoding format of the computer before. Computers only understand binary when reading data. For computer, it can only recognize binary. That is, it only recognizes 010101. For example 192.168.1.1. It doesn't know these points. Then, for binary. In fact, it is convenient for the computer to process. Some students may ask, how did the 0101 pass? Since the computer can only recognize 0101. After that signal is transmitted on the current physical link. How did it become 0101? This is what each device's network card does. Such as electrical signals. We use high and low frequencies to represent 0101. Then it is converted by the network card. Finally converted to binary. Then let the device handle it. But everyone think about a question. Since it can only recognize binary, why do we now see IP addresses in this format? Because binary is not very easy for us to deal with. When we configure in the future, an IP address is a 32-bit binary number. You go to assign an IP to an interface later. Do you have to knock 0101 32 times? It's too much trouble. So, because we humans are not easy to deal with, so a decimal system was developed. So my set of numbers above, it's called decimal. Decimal means every decimal. Maybe because we grew up. I've been learning decimal. So everyone has become accustomed to decimal. That's easy to understand for binary. It is every 2 into 1. You will see that binary has only 0 and 1. Only 0 to 9 in decimal. That is, there are no 10 in decimal. Hexadecimal is no hexadecimal. There are no 2 in binary. So we will also talk about base conversion today. First of all, you need to know the 32-bit binary number is a format of an IP address. We can write it as 4 sets of decimal numbers. The largest single digit in a decimal number is 9. Everyone can see a total of 4 groups. 192, 168, 1 and 111. A total of 4 groups, separated by 3 dots. We refer to this format as dotted decimal. This is the composition of dotted decimal. So you will find formed so far conversion between binary and decimal. That is 32-bit binary number. It can be written as 4 sets of decimal numbers. This is a core transformation of it. For the number of digits, the value expressed by each number in each bit is different. Back to front. The later the number represents, the smaller the value. Everyone starts from the basics. For example, I write a 101. We calculate in decimal. It's called a bit. This is called 10. This is called the 100. Then everyone will find, in this bit, the 1 represents the 1. This 0 represents 0 times 10. And the 1 in this bit is 1 times 100. If it is 201. Here are 2 100. Everyone will find each digit if it is in a different number of digits. In fact, the values it represents are not the same. Followed by a small value. Large value in front. If a digit has no way to represent the current value. For example, now want to represent a 10 in decimal. But a single digit can only represent a maximum of 9. That now wants to mean that 10 can only go forward by 1. This one becomes 0. 1 step forward. 1 to represent 10. It's called decimal. That binary is the same thing. 1 bit of binary represents at most 1 0 or 1. How to express a 2 in binary? There is only one 1 in the single digit. If you want to express 2, you can only move forward by 1. Turn this bit into 0. Which one is taken as 1? It's called carry. These are what we call bases. The following are the rules of the base. Binary 0 and 1 in different bits. The meaning is also different. No matter which base. If a bit represents a value of 0. In fact, this 0 means that it will never take a value. Then if it is 1, it represents the value. Because it has only 2 variations per bit. 1 means that this person has. 0 means that this bit does not. And the information we express should correspond to different digits. To correspond to a different number of digits. For example, I want to express a 1 in binary. In fact, the decimal represents a 1. Now here comes the problem. What if I want to express a 2 in binary? Okay. 10. 'Cause I'm going 1 step forward. 10 is 2 in our decimal system. If a 3 is expressed in binary, the last bit is 0 plus 1. So it's 11. In decimal it represents 3. Because it's too slow to write them down one by one. So I just wrote it in multiples of 2. If a 4 is expressed in binary, because 11 represents a 3. So further forward you want to say 4 is 100. Now the difficulty level up. What if I now want to express an 8 in binary? Let's take a look. The last digit is 1. Represents that the value of this bit is 1. This 10 corresponds to. My bit value is 1. Stands for 2. So actually if there are 3 ones here, it stands for 7. If I want to express 8, I have to move forward 1 bit. It's 1000. Everyone will find. When we finish writing these now. In fact, we should write it more disciplined like this. That is, align the last bit. It will look more beautiful. You will also find that there is a rule in it. When the last bit is 1. Actually it stands for 1. When the second to last digit is 1. It stands for 2. When the third to last digit is 1. It represents 4. When the fourth to last digit is 1. It represents 8. So it stands to reason that if all 4 bits take the value of 1, then add the previous values, is equal to 15. So if I now want to express a 16, just add 1 to the original. We will find 1 plus 1. 1 plus 1. Then carry over. Recarry. Then it becomes 1 and 40s. Represents a 16. In fact, this is a conversion between the bases. 4 digits can only represent a maximum of 15. Then if I want to express 16, I can only go 1 step further. Now the 4 ones actually represent 8 plus 4 plus 2 plus 1. In fact, the maximum it can represent is 15. So I want to express 16 words. It must be 40s. Stands for 16. The rest can be pushed according to the rules. Then if 50s represents 32. If 60s represents 64. If it is 70 represents 128. You can do the math after class, according to the method I gave. Okay. Now I'll give you a different way of writing. Correspondence between binary and decimal. We might as well write, assuming that each bit takes a value of 1. We can convert these 1. When the last digit is taken as 1. Here it represents 1. This is the last. Then here are 2. Here are 4. Then go forward to 8. This table is derived from our previous calculation. A value of 1 in the last digit means 1. Corresponding to this bit is 1. If the first bit is 1, it corresponds to this 170. Stands for 128. In fact, everyone will find we spent so long studying these 8 numbers. It's because these 8 numbers are very closely related to IP addresses. Each of our sets of decimal numbers can be represented by 8 binary numbers. In other words, 32 bits in binary equals 4 decimals. There is a conversion relationship. Actually, the IP address should have been 320101. The reason why it can be written as 192.168. Just because of this. Because all 8 binary can be expressed in decimal. Their lengths are exactly equivalent. Then let's study exactly how they are calculated. For example, what we just wrote. 192.168.1.111. So how exactly does it count as binary? Let's calculate together. Calculating this process is actually quite simple. I will simulate a scenario for you. This scene is quite interesting. Suppose I now draw a square. We divide it into 8 equal parts. These 8 equal parts correspond to the previous values. The top is 128. Then down to 64. 32. 16. We are now going to perform a calculation. Suppose compute 192.168.1.111. We're going to take a decimal number like this. Convert it to a 32-bit binary number. We're going to do a transformation. Now we're going to convert it to 0101. You can also calculate it yourself. Can be hit on the screen. First, let's simulate a scenario. We call this kind of algorithm the number crunching method. This is the most basic method. We express each group in 8-bit binary. That is to say, 192 I want to take 8 binary representation. 168 I will also take 8 binary representation. I take 8 binary representations for each group. In the end I followed the order. Arrange it in order to get a result. Then I draw this shape on the left. It is to simulate a scene for you. Like you are now the boss of a company. Let's say you have 4 employees. 192 respectively. 168. 111. Say you want to give them some rewards. That for employees. You have some different handling mechanisms. If you do a good job, you will be rewarded more. For example, the first person does the best. You're going to buy it something for $192. Suppose these scenes on the left are something on the shelf. Cheaper and cheaper from top to bottom. So it's up to you to spend all your money. How much can you buy? Let's first calculate this 192. If I take this to buy 128. Can buy. 192 equals 128 plus 64. From top to bottom. Definitely pick the expensive ones first. When will the money be spent? 192 can definitely cover 128. So here it is set to 1. This bit must have a value of 1. Because 192 can cover 128. Equal to 64. 64 is exactly the price of the second thing. That's the equivalent of being able to afford this. So the value is 1. After buying 64. The following is 0. It's like the 2 most expensive things you've bought. Then you won't be able to buy them all. So it is equivalent to all take the value of 0. After we calculate such a value, we sort from top to bottom. 2160. Then it represents 192. Let's look down at this 168. First of all, 128 can be bought. 168 minus 128 equals 40. That 64 can't be bought. Then the value is 0. 32 is available. Value is 1. 16 can't buy it. Value is 0. 8 is just right to buy. Value is 1. After buying 8. After that, all values are 0. So the binary representation of 168 is 10101000. We won't talk about the third one. This one can only buy the bottom one. Then there are 7 zeros in front. We look at the last one, 11. First of all, 128 can't buy it. Value is 0. 111 minus 64 equals 47. Also equivalent to 64 is affordable. Value is 1. 32 can also afford. Value is 1. Then subtract 32 from 47. Equal to 15. 16 can't afford it. Value is 0. The sum of the following is exactly 15. So you can buy it later. All values are 1. So now the binary representation of 111 is 01101111. So now these 4 sets of numbers. Let's put them in order. We line it up. That's the equivalent of a 32-bit binary number now. Actually, it's not as difficult as you think. When many students first learn base conversion, always find binary and decimal conversions particularly difficult. That's because people are too lazy to do the math. If you think it's a little more difficult, then every time you count, you can list these numbers first. In fact, wait until you basically finish the whole stage. You'll be familiar with it soon. Okay. It's in decimal. Below is the binary. They are converted using such a method. If you think this method I'm talking about not very easy to understand, then you can find another way. I think this should be the easiest way to remember. That is, for now, the overall address expression is like this. So now I want to ask you another question. 32-bit binary. If I want to express it as a decimal IP address. So what is the maximum IP address? How small is the smallest? We can use a binary calculator. This calculator can be turned into a programmer's calculator. Programmer's calculator is binary from bottom to top. Octal, decimal, and hex. For example, in hexadecimal I write an A. Binary it is 1010. Represents a 10. 10 in decimal. In octal, every 8 in 1 is 12. Octal is not used much. What we use most now is binary, decimal, and hex. Hexadecimal is actually the same thing. As far as the NA stage is concerned, the most important thing is the conversion between binary and decimal. If you usually write a decimal, you're not sure how much. You can check it here. For example, we write a 192. Binary is 11000000. For example, write another 168. Binary is 10100000. Finally write a 111. Binary is 01101111. This is a calculator. Today we're going to talk about subnet masks. There is also a calculator for the subnet mask. Specifically to calculate it. We can see it later. So let's go back to that question. If the 32-bit binary is expressed as a decimal IP address, what is the maximum address that can be expressed? And what is the minimum address that can be expressed? Okay. For 255s and 40s. That is. For 32-bit. If all 32 bits are set to 0. Must be the smallest value. That is. For IP addresses. Current max and min. It's actually pretty well calculated. The smallest representation is all variable binary. Are set to 0. Actually 32 zeros. Every bit is 0. 0.0.0.0. The largest representation is all variable binary. Are set to 1. So what is the result of my calculation? The result is to add from 128 to 1. Is 255. Remember this number. 255.255.255.255. That is. One of the 32 bits of the final expression. Written in dotted decimal. Is 4255. You should know these too. This is what we call max and min. Everyone will find. Since IP addresses have a maximum. Have a minimal. That's actually 40 to 4255. This is the overall range of IP addresses. Then I will give you a simple question. Let's do the math. And this question. It is also related to the content of the next part. Let's take a look. 11000000. This is the first. 11100000. Then 11110000. 1 at the end 11110000. Now it's a binary. Let's calculate the corresponding relationship in decimal. Just add the first 2. Add the first 3. Add the first 4 bits. Add the first 5 digits. So let's do a quick calculation. 192.224.240.248. First of all, it must be correct. I want to ask you a question now. Is this an IPv4 address? Do you think this is a bit strange? I believe that it is difficult for everyone to see addresses in this format. Most of the students think it is not an IPv4 address. For our IP address. No matter how strange it looks. But it only needs to conform to the configuration format of the IP address. It is a correct IPv4 address. It is in the interval. And everyone is. It also does conform to the config format. So it's an IPv4 address. But you have to think about one more question. That means we are in the network. Can the IP address be assigned at will? We all know. Devices that want to communicate must have an IP. Then this IP is not as much as you want. It is indeed an IP address. But it is not particularly in line with our configuration habits. So what are our usual configuration habits? For IP addresses. There is a standardized organization in the world. Is dedicated to managing and assigning IP addresses. This organization is called IANA. It is an allocating authority for Internet addresses. It divides the entire IP address into 5 categories. Including your future study of IPv6 is also managed by this organization. Let's briefly summarize. Divided into 5 categories of ABCDE. Let's start with the first one. Class A address. For Class A addresses. 32 bits in total. Usually 32 bits are divided into 4 octets. We must first notice. First bit of first octet. Must be 0. That is. The first digit of 32 bits must be 0. I don't care what's behind. This format actually restricts only the first. It doesn't matter what happens after. The first bit must be set to 0. So now there is a new problem. If now the first digit of an address. Set to 0. So what is the current address? How big is the largest? How small is the smallest? First of all, how small is the smallest? The first value is 0. Then the last 31 are all 0. That is, minimum is 0.0.0.0. So what is the maximum? Okay. The maximum is from 127. Everybody can count. Since all values are now 1. Is 255. That first one represents 128. In fact, the maximum is the sum of the last 7 digits. There is no restriction on the number of digits in the rear. The last 31 digits are all 1s. Except for the first octet special. The back is 255. So in fact, the range it expresses is 4255. That is, 3 255s are preceded by a 127. This is a range of it. So you will find Class A addresses actually define an interval range. Okay. We next look at Class B addresses. Class B addresses are actually similar to Class A addresses. It specifies the first 2 bits of the first octet. Must be 10. The minimum format is 128. The smallest is actually the first value of 1. The rest are all 0. The first value of 1 is 128. The last 7 digits are all 0. No value. Then the maximum is 255 minus 64. Is 191. Okay. Although no one has calculated the answer. But we all know how. In the end, this value is not the most important. We know what counts that counts. The above are Class B addresses. Let's move on to Class C addresses. For Class C, in fact it will have some of the same places. It specifies the first 3 bits of the first octet. Must be 110. So they are actually connected to each other. The minimum format of this format is that the first 2 digits are 11. Then everything after that is 0. That is, 250 minus 32. Is 192. The biggest is 110 followed by 5 1s. Okay. Is 223. We have finished the ABC class addresses above. Actually, we're already halfway there. Let's stop. Let's not talk about Class D addresses. Because Class D is actually the same format. ABC 3 types of addresses we call them. Unicast address. For equipment, there are only 3 types of addresses in ABC. It can be configured on the interface of the device. Do you remember what unicast is? I mentioned some in the last lesson. When we communicate one-on-one. Like the second floor. We are going to do data encapsulation. Then package. Layer 2 encapsulates source MAC and destination MAC. Layer 3 encapsulates source IP and destination IP. Then one device communicates with another device. We call it unicast. Only the 3 types of addresses ABC are called unicast addresses. It can be configured on the interface of the device. Or for terminal. Configured on the device's network card for identification. For equipment. When you go to address configuration, all configured addresses are ABC Class 3. This is called a unicast address. The remaining 2 categories are different from them. We mentioned it last class. Except for unicast. Also broadcast and multicast. Let's talk about multicast first. We didn't go into great detail before. Because at this stage we don't need to understand the whole multicast. This belongs to the knowledge of IE. I told you about the format of the MAC address before. A MAC address is a 48-bit binary number. We want to measure whether a MAC address is unicast or multicast. Depends on whether its 8th bit is 0 or 1. Then everyone should know. For the network layer, there is also a special segment in the IPv4 address for multicast services. So let's learn about Class D addresses now. Class D address. It looks from the format. Same as the others. Because it specifies the first 4 bits of the first octet. Must be 1110. So it doesn't actually change much in the format. Then its smallest representation is 224. The biggest thing is all 32 bits except the 4th bit are 1. That is 239. This is the range of Class D addresses. But only when you learn IE. Access to the real multicast service will only come into contact with Class D addresses. Then for a Class D address, it also has its own characteristics. It has a very clear stipulation. A Class D address can only exist as a logical address. It cannot be configured as a real address. But only in logic. It cannot be configured on the interface of our device. We all know. The device interface needs to carry out 3-layer communication. Is to configure the IP address. The assigned address cannot be a Class D address. You can understand a logical address as a virtual address. Let's say we're going to send data. Can be sent to a virtual address. And other devices can receive information about this virtual address. We call it listening. But this address, it can't be paired with any one device. Everyone can understand. It is a logical address generated by simulation. Configuration is not allowed. Multicast is knowledge belonging to IE. Slightly harder. We can't get in touch at the moment. So we are actually the most important now is the first 3 categories. ABC class. That is unicast address. This is what we will configure in the future. The last one is a Class E address. For Class E addresses, it also has its own corresponding regulations. It specifies the first 4 bits of the first octet. Must be 1111. Its minimum is 240. The maximum is that all values are 1. Actually 4255. So you will find the minimum of Class A is 40S. The maximum of E is 4255. That actually divides the ABCDE 5 categories. Our address range is from 40s to 4255s. Class E addresses are also special. It is a reserved address. The reserved address we call the laboratory. It is used for military or scientific research to do some research. This address is sealed. Temporarily unavailable to anyone. We can now use only the above ABC 3 categories. That is to say, what can really be configured are the 3 of them. Class D addresses we can also use. But it will involve some applications and protocols. When adding groups in the future, different protocols use different multicast addresses, including different applications. The logical multicast addresses they use are also different. A dynamic routing protocol will be learned in NA, called OSPF. At this stage, a multicast address will be touched. Are 225.0.0.5 and 6. That's not our focus right now. In fact, everyone knows that OSPF will use multicast. We have now introduced 5 categories. Class E addresses are reserved. You can't use it. But we can use the ABC class address. Please pay attention. Although Class ABC addresses can be used, but not all addresses of the ABC class can be used. There are some special ones that cannot be used.